All right, welcome everybody. Today we're going to talk about lesson number 77. This is the fourth and final conic called the hyperbola. Please note that even though this is the final conic, we're going to do part of the operations today in lesson 77, and then we're going to do part of the operations in lesson 78. So please keep that in mind as you start working on your take-home quiz. There are the problems for homework 77 listed. It's a little bit shorter since I know that homework 76 was a little bit on the longer side. Yet another Desmos link was sent to you in case you want to see how the different variables affect the shape of the hyperbola. This is an especially good one for anyone who needs more help with the visuals. So a hyperbola, the simple definition of a hyperbola is basically it's an ellipse that's been flipped inside out. If you're looking to get a little bit more precise, in an ellipse, you were talking about the fact that the distance between the points and the foci was a fixed sum. Now, in a hyperbola, you're talking about the fact that it is a fixed difference. So if you take a look at these pictures over here, again, what they're saying is that the distance from the foci to any point on the graph has to be a fixed distance. And again, notice that since this is essentially an ellipse flipped inside out, the foci are now on the outside. So the two different parts of the hyperbola are called the branches. And again, your graph can either open like these examples, left to right, or it can open bottom to top. And we'll talk about how you know. The line that goes through the two foci, those of course go through the vertices, same vertices that we've been talking about. The line segment that connects those two vertices is called the transverse axis. And then there is still a center of the hyperbola. Talking about the equations, again, notice that there are four different versions, two of which is if the center is the origin, and two of which is the center is something else like HK. H continues to go with the X, and K continues to go with the Y, and you always do the opposite. Notice that similarly to the ellipse, these equations are only true if it's equal to 1. And then the most important thing is probably here at the bottom, the ellipse. The ellipse, you knew if it was going to open up to down or left to right based on who had the larger denominator. When it comes to hyperbolas, you are going to open towards whichever variable is positive. So it no longer matters the size of the denominator. Instead, it matters which of the terms is positive. And again, notice that between the x's and y's, there is a subtraction as opposed to ellipses where it's an addition. So if you take a look at the first version here, because of the fact that the x is the positive variable, that's why the graph is opening towards the x's to the left and to the right. If you notice here in the second equation, because y is the positive variable, that's why the graph is opening up and down towards the positive y and the negative y. The foci, there's a foci equation for a hyperbola. Notice that unlike the ellipse, it's an addition between the two terms, which again, it should make sense that if the equation itself flipped, that the equation for the foci should flip as well. Here are, again, essentially the two different things that can happen. In the example on the left, the positive x is how you know it's going to open left to right. In the example on the right, the positive y is how you know it's going to open bottom to top. And again, please make sure you know that the foci are technically outside of the hyperbola. They live inside those two U shapes. Okay, so then how do you know how to make the graph look symmetric? How do you know exactly how wide those branches should be? Well, in order to guide them, you are going to find asymptotes of the hyperbola. Each hyperbola always has two asymptotes that intersect the center of the hyperbola. Here are the two different equations. Notice that the only difference is whether you put B on top or whether you put A on top. You're going to put B on top if the transverse axis is horizontal. You're going to put A on top if it's vertical. Even though you are technically going to find these equations, you do not have to simplify them, because if you take a look at this picture over here, I'm going to show you kind of an easy way. You'll notice that within that hyperbola, it kind of looks like there's a box there. So you can choose to formally draw the box or not. It depends on how much guidance you need in creating your graphs. But basically, wherever the center of the hyperbola is, that's where you're going to start always. And you're going to start with whatever the y value is, which it will always be the k. Then, depending on whether it's B over A or A over B, you are then going to calculate that slope, rise over run, from that K. So let's say that you were talking in this case here about trying to find out exactly where the asymptotes are from the center of the circle, you would go up A and right B, or up B and right A, depending on which of the formulas that it was. That will essentially give you a point right here. Then if you go back to the center, you would go up and left, which would give you a point here. Down and right would give you a point here, and then down and left would give you a point here. So some people find it helpful, in addition to drawing the dotted asymptotes, they like to draw the dotted box. Not required, do whatever works best for you. The thing you most want to notice is that if you're going to draw that box, notice that the point should always be in line with the vertices. So in line here, in line here, and basically in line everywhere. So again, draw the box or not, depending on how confident you are in your hyperbola abilities. Just like all the other problems, you're going to be asked to sketch using the key points. And when it comes to hyperbolas, the key points are the center, the foci, and the asymptotes. And also the vertices, it should say. And then there's the formula for the foci. And again, it's addition as opposed to yesterday where it was subtraction for the other. And again, each of these, for the next couple of examples, they all should also have vertices in there. So even though it doesn't say so, please make sure that you know to do that. So 4y squared minus 9x squared equals 36. And again, we're going to talk in tomorrow's lesson a little bit of how you know how to name that conic. Without actually graphing this, how would you know just by looking at it that 4y squared minus 9x squared equals 36 was in fact a hyperbola? Well, the fact that there are two different square terms, that's how you know that it can't be a parabola. The fact that there are two different coefficients, is how you know that it can't be a circle. And the fact that there is a subtraction sign between them as opposed to an addition sign, that's how you know that it's a hyperbola as opposed to being an ellipse. But again, tomorrow's lesson, we'll play a little game of name that conic. So again, this only works, all the hyperbola stuff only works if you are in fact equal to 1. So the first thing I'm going to do is I'm going to divide everything by 36. If I divide everything by 36, I'm going to get y squared over 9 minus x squared over 4 equals 1. Then notice that the positive part of this equation is with the y. So a positive y is how I know that the graph is going to open like this, up and down. So given the fact that I know that the positive is with the y, that means that 9 is a squared, which means that a is 3. That means that 4 is b squared, which means that b is equal to 2. So then the center, because there is no h and there is no k, the center is 0, 0. Then the vertices. So the vertices, again, because the graph has to open up and down, you have to go a unit up and down from the center. So that's how you know the vertices are going to be at 0, 3 and 0, negative 3. Then the foci. So to find the foci, c squared is going to be equal to a squared, which is 9, plus b squared, which is 4. That means that c squared is going to be equal to 13, which means that c is going to be equal to the square root of 13. No need to make that into a decimal, although I guess you could if you want to. So the foci have to be the square root of 13 units above and below the center. So the foci are going to be at 0, comma, plus or minus the square root of 13. And again, you could separate them like I did the vertices or write them as a plus or minus. I really don't care, so do what works best for you. Then in terms of the asymptotes, so you would have to look back on the previous slides at the formula for asymptotes. Because of the fact that the graph is opening up and down, the formula for the asymptote is going to be k plus or minus a over b times x minus h. And again, because you have access to all your notes, you're never having to memorize anything. So the k value in this case is 0. Plus or minus, the a value is 3, the b value is 2, the h value is 0, which means you're going to get 0 plus or minus 3 over 2x. And again, simplify it if you want to, but I'm perfectly fine if you don't. Now that you have all this information, here's where you're going to make the graph. And to kind of make things a little bit simpler, I made them ahead of time online just because I'm having a hard time with my stylus making the different points. And I thought that this would maybe just make things simpler. So notice that this is the center of the circle, which is at 0, 0. Notice that here's your first vertex. Here is your second vertex. Notice that here is one focus. Here is the other focus. Those are the square root of 13 units away, which is approximately 3.606. Then in terms of the dotted lines, which again are the asymptotes, if you look back in your example there, the fact that you are doing y equals, and again, if you were to simplify, would basically be plus or minus 3 over 2x. So let's say you wanted to create the box. You would start at the center, then you would go up 3 and right 2. Starting at the center again, you would go up 3 and left 2. Back to the center, down 3 and right 2. And then back to the center, down 3 and left 2. So that would essentially be the box, which again, you can draw or not, depending on how much guidance you need. But if you're going to draw the box, you have to make sure that those points always line up with each of the vertices, because that's how you'll know if you're doing it right. Okay, another example here, sketch each hyperbola. And again, don't forget that in addition to those things that are being mentioned, you also have to find the vertices. Sorry about that little typo. So the nice thing here is it's already equal to 1. Notice that the fact that the x this time is the positive. So the fact that it's a positive x is how I know that the graph is going to open left to right. Those are going to be my 2 branches. So because of that, there we go. The a squared is always going to go with the positive thing, and the b squared is always going to go with the negative thing. So if a squared is equal to 144, that means that a is going to be 12 and b is going to be 5. And again, they don't always have to be nice numbers, but I'm just trying to make everybody's life a little bit simpler. So the center, opposite h, opposite k, is going to be negative 3, 2. The vertices, so the vertices have to be a units in the direction that it opens. So 12 units to the left and 12 units to the right. So that is going to give me 9, 2 and negative 15, 2. Then the foci, so again, c squared is equal to 144 plus 25. That's going to give me 169, which is a perfect square. So C is equal to 13. So that means that the foci have to be 13 units away from the center in the direction that it opens. So 10, 2 is one of the foci, and negative 16, 2 is the other focus. Then for the asymptote, okay, again, because of the fact that this graph is opening from left to right, that's how you know that it's going to be B over A as opposed to being A over B. And again, you don't have to memorize any of these equations. You simply have to go back and be sure to utilize them. Okay, so again, if we plug in the appropriate values here, it's going to be 2 plus or minus B over A is 5 over 12. And then x plus 13. Oh, nope. X plus 3. Sorry about that. Okay. Oh, excuse me. Now that we have all that information, again, I did the graphs ahead of time just because I think it would be a little bit easier. So notice that this is the center of your hyperbola. Then 9, 2, negative 15, 2. Those are your vertices. Your foci, slightly outside. And then the way that you would try to accurately, as best you can, draw those asymptotes would be to start at the center. Looking at the equation that we found on the previous slide, again, no need to simplify, starting at the y value of 2, you would have to go up 5, right 12, up 5, left 12, down 5, right 12, and down 5, left 12 if you were trying to create the box. That's going to give you a point here, a point here, a point here, and a point here. So draw the box if you think it's helpful. Don't draw it if you don't need it. But if you are going to draw the box, again, make sure that it lines up exactly with those vertices. The only way that these problems get a little harder is, again, if we have to complete the square. And this is the hardest completing the square so far because of the fact that there are negatives. So we do want to make sure that we are extra careful when we do so. So here for problem 3, notice that the 9x squared is the only x term. So no completing the square necessary for that. Notice that when it comes to the y's, if you remember from the previous lesson, you have to factor out whatever is in front of the y squared. And in this case, you're always going to be factoring out something negative. So negative 4 away from negative 4y squared is going to leave you with a positive y squared. Then if you take a negative 4 away from a positive 8, you're going to, wind up with a negative 2y. Leave a little space and move the constant over, which makes it a positive 40. Then half of negative 2 squared is negative 1 squared is 1, so plus 1. But again, because of this negative 4 on the outside, you didn't really add 1. You actually subtracted 4, which means you need to make sure that you subtract 4 on the right-hand side as well. This is kind of the number one place where people go wrong because they forget about the negative in front. So try not to do that. So 9x squared is good to go by itself. Then negative 4. Make sure you write it as a quantity squared, which is y minus 1 squared is equal to 36. Looking good so far, except for the fact that we have to be equal to just 1. So if you divide every term by 36, you're going to get x squared over 4 minus y minus 1 squared over 9 equals 1. Notice that the x is the value that is positive. So again, that's how I know that the graph is going to open from left to right. Let me go ahead and proceed to the next slide so that we have a little bit more room. So if we go on to the next slide here, underneath the, let me write this again. So x squared over 4 minus y minus 1 squared over 9 is equal to 1. That is going to be my a squared, the positive. This is going to be b squared. So that means that A is 2 and B is 3. The center of this hyperbola is going to be 0, 1. The vertices have to be A units in the direction that it's opening. So to the left and to the right, 2 units. That's going to give me vertices of 2, 1 and negative 2, 1. And again, feel free to use a plus or minus when it's appropriate. The foci, so the foci are going to be equal to c squared is a squared 4 plus b squared, which is 9. That's going to be equal to 13, which means c is equal to the square root of 13. So your foci are going to be plus or minus the square root of 13, comma 1. And again, use plus or minus or not. It really makes no difference to me whether you want to separate them or not. For the asymptote, because of the fact that it's opening horizontally left to right, that's how I know I'm going to use the equation of k plus or minus b over a. So in this case, it's going to be 1 plus or minus 3 over 2. And then x minus h, there's no h, so it's just going to be 3 over 2x. That is all the information that I need. And again, to draw my hyperbola, I've already done that for us. So here's the center, 0, 1, 2 vertices, 2 foci, and then from the center, you would, of course, go up 3, right 2, up 3, left 2, down 3, right 2, and down 3, left 2 to kind of estimate those asymptotes, which again, you should always kind of do as dotted lines and draw the box if appropriate. So one last one, and again, if you're feeling confident, perhaps pause and try it. If not, then let's go ahead and do one last one. So notice here that there are multiple x terms. That's how I know that that is the square that I'm completing. So I'm going to put those together whilst I factor out the 4. So that's going to give me x squared plus 2x, and I'm going to leave a space. Minus 3y squared stands alone, and of course, subtract the constant to the other side. Half of 2 is 1, squared is 1. But again, because of this 4 on the outside, I didn't really add 1. I really added 4. So from here, I'm going to get 4 times x plus 1 squared minus 3y squared equals negative 12. It's the first time that we've been equal to a negative 12. The truth is it's not an issue right now. It might not ever be an issue because we cannot decide anything about this problem unless we go ahead and make it equal to 1. So very carefully now, when I go ahead and divide both sides by negative 12, that's going to give me a positive 1 on the right side. If I divide a positive 4 by a negative 12, that's going to become negative x plus 1 squared over 3 plus y squared over 4. So basically, if you want to rewrite that to look the same way we've been doing, you're going to do y squared over 4 minus x plus 1 squared over 3 is equal to 1. And you have to realize that, again, whatever is positive, so in this case, positive y, that's how you know that the graph is going to open up and down. So don't make any decisions about your hyperbola or about any of these conics until you have it in the appropriate format. So again, another screen here just to give us some extra room. So write that again, y squared over 4 minus x plus 1 squared over 3 is equal to 1. That is going to make the center of this negative 1, 0. Again, you always come from the x first, the h, and then the k always goes with the y. So from here, remember that the positive is always going to be a squared, and the negative is always going to be b squared. That means that a is going to be equal to 2 and b is going to be equal to the square root of 3. So the center is negative 1, 0. And again, we already said that because of the fact that the y is positive, we know that it's opening up and down, which means that the vertices have to be 2 units above and below the center. So negative 1, 2, negative 1, negative 2. C squared is equal to a squared plus b squared. Oops, that's a 3. So that gives me an answer of 7, which means that c is equal to the square root of 7. So the foci are going to be negative 1 and then plus or minus the square root of 7. And again, use the plus or minus if you would like. Because of the fact, so for the asymptote, because of the fact that the graph is opening up or down, that's how I know that the equation is going to be a over b. So k is 0, so plus or minus 2 over radical 3, and then x, and again, x plus 1. And again, really no need to simplify that, okay? What you might want to do, though, so the slope is 2 over the square root of 3, which is 1.73. So as you go to estimate those asymptotes, you're basically going up 2 or down 2, and then left, right, 1.73. So here's our final hyperbola. Again, notice the center, notice the vertices, notice the foci. And then, of course, when you were to do your asymptotes, these are going to be slightly estimated. You're going to go up 2 and then over 1.73. So there might be a slight estimate. Again, that's where the box might be helpful, but certainly that's up to you.